Okay.
We love 49ers.
That's true. Here's why we need to. Here's why we need this lesson. You might say, well, we already found missing sides, and that's true. Here's what we did on the last lesson. If we had this triangle, if you knew that this length was 7, and you knew that this length was 25, then you could use Pythagorean theorem and find that that length was 24. So that's not what I'm talking about with finding missing sides. All the problems we've done so far to find a missing side, we've already known 2 sides. But what if the only thing we knew is that side was 7? And we didn't know anything else. But we don't know if this other one is 24. We don't know if that other one is 25. All we know is that one side is 7.
Doesn't have a capture button that says this is a Pythagorean triple?
My point is, if we only know one side, can we use Pythagorean theorem? No. Here's an initial piece of information, though. Put this as a 20-degree angle. Now we know an angle and a side. That's actually enough information to find other missing sides. If we know an angle and a side. Okay? It's not trying to prove that triangles are congruent or trying to prove that they're similar. So we have to know one side length and we have to know an angle for this to work. Okay? Well, we know that this one's a 90-degree angle. We have to know another angle on it. Okay? That's a good one. We have to know another angle on it. Okay? What if I asked you to find now the measure of that side right there? What is this whole unit about? Not this lesson, but the whole unit. What are we learning about in this unit? Not the Pythagorean theorem. We've used it to do what? Sine, cosine, or tangent. You guys, the whole unit is about trigonometry. Don't you think this might have something to do with trigonometry? Take a look at the angle I've given you. 20 degrees. What side is this over here? What side is it? Opposite, adjacent, or hypotenuse? And what side is this? Adjacent. What trig function does that sound like? Opposite and adjacent. Sounds like tangent, right? Because we have the opposite side and we're trying to find the adjacent side, we're going to use tangent to solve this.
So we could put 90 degrees over 20 degrees?
Hold on. There was a question here and then we'll go here. What's that?
How do you know that 7 is an adjacent?
7 is the opposite side. Because this is where the angle is. This would be theta. So if this is where the angle is, and that's across from it, and this is adjacent to it. So instead of doing tangent of theta, theta only means we don't know what the angle measure is. But don't we know the angle measure? It's 20. So instead of doing tangent theta, we do tangent of 20. Okay? What's the ratio now? What's the ratio? Tangent is opposite over adjacent. So it'd be 7. And instead of doing question mark, let's just make this a little more mathematical. Let's do it x instead of a question mark. The tangent of 20 is 7 over x. 20 is inside of the tangent function. We can't mess with 20. Okay, we got to solve for x. Okay, you guys writing and listening? I'm going to go over a couple of examples, but I don't want you guys to get to home and say, well, how do we do this? It should be in your notes. Take notes. Your first question, rather than raising your hand saying, I don't get this, what's the first thing you should do when you're not sure of a problem? Look in your notes. Look in your notes. Not that I don't want to help you guys, but you need to learn how to start helping yourselves. When you guys leave school, and some of you go on to college, you got to be able to teach yourself sometimes. You got to be able to take notes from a professor, and then when you're doing your homework, instead of calling the professor, using your notes to figure things out, you guys got to get used to that kind of stuff. Okay? You shouldn't just automatically raise your hand and say, I can't do it. No, can't do this. Use your notes. Try to use your brain and figure things out. Okay? Here's how you solve something like this. We're solving for x. X is on the bottom of a fraction. Okay? What if we multiplied by x on the right side? What would happen if we multiplied by x on the right side? That's if it was x times x on the top. What if we have an x on the top and an x on the bottom?
7x divided by x.
They would cancel, you guys. If you have an x on the top and an x on the bottom, they cancel. But if you multiply by x on one side, you have to multiply by x on the other side. So now we have x times the tangent of 20 is equal to 7. What is it that we're trying to solve for? X. What's happening to x right now? It's being multiplied by the tangent of 20. What's the opposite of multiplying? So we're going to divide by the tangent of 20. Tangent of 20 divided by there you go. Tangent of 20 divided by tangent of 20, those cancel. So x equals 7 divided by the tangent of 20. And this is where if you don't have a calculator, you're going to get dot points. Turn on your calculator, type in 7 divided by. Now those who are following along and trying this out, please do this before you hit enter. Your calculator, and even if it's on your phone, they have different what are called modes. My mode button is right here. If you have a graphing calculator, it's probably in the same spot. Hit the mode button. The third option down says either radian or degree. We should be in degree mode because we're talking about 20 degrees. It's an angle measure. My degree is highlighted. If your radian is highlighted, you're going to get the wrong answer. So make sure degree is highlighted. If you're not sure how to change the mode on your calculator, I can come and take a look. But if it's in the wrong mode, your answer's going to be wrong, and I'm going to have to mark all your answers wrong. Okay? It's in degree mode, so now it's 7 divided by tangent 20. Hit enter. So that missing side length is approximately 19.2. On your calculator, you type in 7 divided by, because that's exactly what it is here, 7 divided by the tangent of 20. There's no way that you guys can do this without a calculator. There's no way by hand to do 7 divided by tangent of 20. Okay? It would be blown. Yeah.
I did it on my hand. I got 19.32.
What's that? We will.
Which one are you supposed to switch it to?
Degree mode. Should be in degree mode. The tangent button. They're right here in the middle. Okay, let's write this all down in a table so you know the steps. Not by hand. Okay. Let's do a next example, and as we're doing this, we'll write down some steps so you guys can have a list of steps. If we knew that this was a 48-degree angle up here, and we knew the hypotenuse was 17, and I'm asking you to find this length right here. Okay. Step 1 is to choose the correct trig function. You can't just choose one at random. You can't look at this and say, well, I like tangent, so I'm going to use tangent. Tangent wouldn't work here. You have to choose the correct one based on the information. So based on where the angle is, what side are we trying to find? We're trying to find the adjacent. What side have we been given? The hypotenuse. So using those two sides, you got to choose the trig function. Adjacent over hypotenuse is the cosine. The cosine is the only problem that will work here. Okay? So we're going to use cosine. Step 2. After you've chosen the correct trig function, set up an equation and solve for x. I mean, there's only 2 steps here. Set up the equation and solve for x. So for this question here, the equation is going to be cosine. And how come we don't do cosine of theta?
Because we know it's 48.
We know it's 48. Theta means we don't know the angle. Here we know the angle. It's 48. Cosine of theta equals. Remember the definition of cosine. It's the adjacent length divided by the hypotenuse. So here x is on the top. Last part we did x was on the bottom. Sometimes it'll be on the top, sometimes it'll be on the bottom. If you want the easier problems, when x is on the top of these fractions, those are much easier. when x is on the bottom, it's a little tricky to solve. This one,
There's one step to solve this.
what's happening to x right now?
Being divided by 17.
It's being divided by 17. What's the opposite of that?
17 whole.
Multiply by 17. The 17 on the bottom cancels with the 17 on top.
And 17 goes to this side.
So x is equal to 17 times
Cos 48.
the cosine of 48. Now let's get one thing straight. I don't want to see this mistake happen ever. So listen carefully. Do I have your attention? This 17 cannot multiply the 48. The 48 is inside of a cosine function. There's nothing you can do to that 48. Okay? The 17 just multiplies in front of the entire thing. You never ever multiply the 17 with the 48, or any number in front for that matter. If a number is inside of a trig function, it's going to stay what it is.
So how you would write 17 and then cos 48.
So on your calculator, you type in 17 times the cosine of 48.
46.32.
It's 11.4.
What's the third step?
There's no third step. You set up an equation to solve it. You choose the correct trig function, and then you set up an equation to solve it. All right? Try this one. Can't do it.
You can.
I cannot. This angle is 35 degrees. I'm asking you to find this side,
So it's going to
and I'm going to tell you that this side is not.
so it's
So just try to solve this on your own.
try to solve this on your own. Write it down, get as far as you can get without a calculator.
You can't just use any random trig function. It has to be the one that fits this picture.
Switch what?
Okay, hold on. For smashing your foot.
Mr. Ruff, I know the answer about calculator.
Just for 5 minutes.
Mr. Ruff,
Yo.
maybe.
I can see my numbers do that. I can see why I can see my numbers.
I want my shoes, $10.
So, we're going to have a volunteer man to call on somebody. Who wants to go up to the board? All right, Michael, go up there. What's that? You got to explain step by step. Again, just put up the answer. Go ahead.
Try this. On this board?
Yep.
Okay, how does this work?
We're going to have to press the button. Button needs to erase it.
So, tell us from start to end.
So, first we have to figure out what this is. And I figured out it was tan.
Now, what do you guys think? Tangent?
I suck at writing like this, guys. So sorry. I need it.
Take some getting used to. There you go.
This is
There you go. Good.
okay.
Now, wait a minute. Did we decide tangent was good? Okay, tangent's good.
And then, yeah. So I put the x above 9.
Okay, stop for just a second. Scoot over so everybody can see it. Now, I wanted to ask a question. Everybody look at that.
What's the flopiness?
Hey, shh, shh, shh. Would 9 over x have worked? Or does it have to be x over 9? It has to be x over 9 because it has to be opposite over adjacent. And in this picture, x is opposite and 9 is adjacent. So it has to be x over 9. Okay, keep going.
Okay, then you multiply that. How do you do this? By, and the top, split that out.
Those cancel. Good.
And then it becomes x.
Yeah, it doesn't like x. There it goes.
Equal to what? 9 times That's horrible.
Ooh, you want to have some more fun? Down at the bottom, hit the calculator icon. Down at the bottom. Yep. Now type it in.
Oh my gosh.
9 times, there you go. Tangent. Hit the over button, the left button, and then you can type in a 3. And then hit enter. Sweet.
Yeah, I know it's 6.3.
6.3.
That's for 5 minutes. 6.3.
Good. Thank you.
Enjoy the fluffiness.
That's okay.
That's how these are working. Let's do one more quick one where x is on the bottom. For some reason, when x is on the bottom of these, it just messes with your mind. I don't know why it's so much different. It's not that much different. Okay, here we go. We got to speed this up. There's a triangle. We know that this one here is, let's say that it's 62 degrees. We don't know the hypotenuse, but we know this side over here is 11. It's the same steps, but for some reason, a problem like this, students mess up on. It's no different. Step 1 is to choose the trig function. None of them?
Sin.
This is the opposite length, right? Opposite.
And what is this? So what's opposite and hypotenuse? It's the sine. So it's the sine of 62 is equal to the opposite length, which is 11, divided by the hypotenuse, which is x. It's no different except that x is on the bottom of this fraction. We solve it a similar way, but it's not quite as easy as just multiplying by 9 on both sides. Here we multiply by x on both sides. So we have x times the sine of 62. It's like the first example we did. X times the sine of 62 equals 11. And now there's just one extra step. What's that extra step? Exactly. Divide by the sine of 62. I don't know why this seems to be so much harder. It's not. It's just as easy. There's just one extra step. So x equals 11 divided by the sine of 62. So 11 divided by sine 62 equals 12.5. Now, you guys, while I explain this next thing, I want you all to stand up for a second, just so you can get out of your seats. Stand up while I explain something. Stand up quick, come on. You've been sitting for too long. You got to get some blood moving. No, just while I explain this. What have we been solving for? Side lengths or angle measures? Side lengths. We've only been solving for side lengths. Okay? We're about halfway done with this. We need to solve for angle measures. Do you understand how that's different? Is an angle measure the same as a side length? No. So the method we're using to solve for side lengths is not the same method for solving for angle measures. You guys need to understand that. They're different. Okay? All right, have a seat. Find missing angle measures. No. Find missing angle measures. Here's example 5. Oh yeah. Draw a triangle.
I have a question, but maybe one day when I ask it, that we will not have one.
Come on, let's go. Zip, zip, zip. This would be an easy question if I asked you to find this angle and I told you that this one was 30. Why would that be such an easy question? Exactly. You add them together and subtract from 180. So if this is 90 and that's 30, what does this one have to be?
40.
60. You have to be 60, right? That's not the type of problems we're doing. If I told you this was a right angle, but we didn't know this angle measure here, could we find that angle measure? No. Unless we use trigonometry. So instead of a question mark, put that as a theta symbol. Okay. Now, if we knew that this side here was 5, and we knew that this was 13. Michael, is this opposite, adjacent, or hypotenuse? Okay, good. What is this one? Now look at listen to what we're saying. We have opposite and we have hypotenuse. It's the sign. The steps are almost the same, except we set up a slightly different equation. Step 1 is to choose the correct trig function. In this case, it's going to be sine, and now we have to use theta because we don't know the angle measure. Step 2 is to solve. We have to do this differently. I need you to look up here. Okay? On the last problem, we were solving for x. X was not inside the function. On these problems, we're solving for theta. Theta is inside the function. So we can't solve for theta unless that function's gone. So divide by 6. Well, that's what we need to talk about. If this were the equation, the square root of theta is equal to 9, would you just divide by a blank square root on both sides? How would you solve this equation right here?
9 times 9.
Not time. What gets rid of a square root? The opposite. What's the opposite of a square root? An exponent of 2. Okay, you can't just divide by a blank square root to get rid of a square root. And the same thing applies here. You can't just divide by the sign of nothing to get rid of sine. Okay? We have to figure out what the opposite of sine is. Just like here, the opposite of square rooting was squaring. What's the opposite of sine? If you have a calculator out, look on your calculator. Look right above the sine button.
-1.
Do you see a button? Look at my calculator if you don't have one. Do you see where it says sine to the -1?
Yes.
That's the opposite of sine. If you want to get rid of a sine function, you have to use that sine to the -1. So, Step 2 is to use, it's called the inverse. Use the inverse trig function. Use the inverse trig function. So in this case, we're going to use the inverse sign. You have to write this correctly. You have to put inverse sign here. And since this is an equation, you have to put inverse sign on the other side. Now what happens when you place an inverse sign right next to a sign? What do you think happens? They cancel each other out because they're opposites. It's just like putting a square root and then a square next to each other. They cancel each other out. If the sign and the inverse sign cancel each other out, what's left on that side of the equation? Theta. And that's what we're solving for. We're solving for theta. Theta equals the inverse sign, bless you, of 5/13. Now one mistake students make is to write it this way. Theta equals 5/13 sine -1.
Wrong.
That's wrong. Why is that wrong? The inverse sign is a function. The 5/13 has to go inside the function in the parentheses, not outside of it like this. So this. So on your calculator, you press second and then, not tangent, second and then sine, and then type in 5/13.
Equals 4.
Equals 22.7 or 22.6. Now, 22.6, what? What is it that we're finding? A side length or an angle measure here? An angle measure. So it's 22.6 what? Degrees. It's 22.6 degrees. Theta equals 22.6 degrees. You have to label it as degrees. If you don't label it as degrees, it's a side length, and it's not a side length, it's an angle measure. These ones I think are actually easier. All you gotta do is use the inverse trig function on both sides. If you have a calculator, it's easy. Then I don't know what you're gonna do. There's online calculators. Matter of fact, the Windows calculator might even have it. If you go to Edit or View and go to Scientific, it's got sine, cosine, and tangent. And then if you hit this inverse button, it changes it to sine inverse, cosine inverse, tangent inverse.
What about the degrees and stuff right there?
Right here is degrees. It needs to be in degree. So you could have done this on your Windows calculator. If you type in
Sick. Let's go have it.
let's see, where's the clear button on here? Clear.
Push this C.
The regular C, bro.
Inverse, there it is. Okay, so if we type in inverse and then inverse sine of 5/13, that didn't work.
Oh, okay.
There you go, 22.6.
You have to do the division and then you have to sign.
You do the division and then you hit inverse sine on this one. It's a little backwards. But even your Windows calculator can do it.
Oh, I can do one more.
Okay, try this one.
It's a diamond.
I'm asking you to find this angle right here. We know that this length is 12 and we know that this length is 9. So find the measure of the angle. Now we can just use any trig function we want, right? Any one of them will work. We have to use the right one. This one's tangent. Tangent of theta, you guys are implying that you have some intelligence. I'm just kidding. The tangent of theta, does it matter if it's 12/9 or 9/12?
Yeah, 12 nines.
It has to be 12/9 because it's opposite over adjacent.
You can actually take that down.
You could simplify it, but we could leave it here and still get the same answer. Now, how do we get rid of a tangent? Inverse tangent on both sides. Remember, this is an equation. You have to do it to both sides. Inverse tangent cancels a tangent, so theta equals the inverse tangent of 12/9, which on a calculator, inverse tangent of 12/9
Why don't you get that everybody with my laptop?
No. 53.1.
I don't even have a laptop.
Now 53.1, what?
Degrees.
Degrees. Put the degree symbol on there. Oh, that was awesome.
That's awesome. Why can't we leave that like that?
There we go. That's how you find missing angle measures. Now let's get something straight. If you're searching for the side, listen carefully, please. If you're searching for the side of a triangle, do we use inverse? No, you use normal trigonometry. When do we ever use inverse trigonometry? Only when you're searching for an angle measure. If you're searching for an angle measure, then you use inverse. Otherwise, you use normal trigonometry for side measure. All right.